Hello, everyone, and welcome to today's webinar, Propane for Power Generation, Why Your Industry is Making the Switch. Before we get started, I'd like to go over a few items so you know how to participate in today's event. You have joined the presentation and listening to your computer speaker system by default. If you prefer to join over the telephone, just select Audio Options and leave Computer Audio, and then dial in to the telephone number displayed. You will have the opportunity to submit text questions to today's presenters by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. Today's webinar is being recorded, and you will receive a follow-up email within a few days for the link to view the recording. I would now like to introduce Sean Whalen, Power Generation SME, Superior Propane. Sean Whalen has over 30 years' experience helping organizations with their power and heating needs. His background in service and operations means Sean has a keen understanding of project cost, impact, and environmental performance. And Sean, welcome.
Thank you, ladies and gentlemen, for taking time today to join us for our webinar, Propane for Power Generation, Why Your Industry is Making the Switch. As mentioned, my name is Sean Whalen, and I am a power generation sales specialist at Superior Propane. Over the next 30 minutes, we will explore the benefits of propane for power generation. We will review both the economic and the environmental arguments, as well as discuss the new environmental legislation. We will look at different solutions, and we will cover the different financing options available to ease the burden on capital budgets. And finally, we will take a closer look at a case study of an aquaculture company that relies on propane to keep its fish farm operational. Today, energy is part of the daily news cycle. Whether it's about the rising costs, conservation, or pipelines, it's constant because it affects households and businesses alike. For many industries, energy costs make up a large portion of their operating expenses, especially those that are remote or have manufacturing processes. And energy costs are rising. Added to that, there are new carbon emissions taxes. There is also a heightened awareness of corporate and environmental responsibility. Now more than ever, making the right fuel choice for your business energy needs matters. Is your business prepared for rising energy costs and the new emissions regulations? In the early days of off-grid commercial and industrial power, there was little choice of fuel options, so operators naturally relied on diesel. Such has not been the case for some time now. In fact, there is a long history of propane-powered applications in remote communities and industries like mining, agriculture, construction, and oil and natural gas exploration, to name a few. Today's engineers and operators have more fuel options, and many are opting for propane. So why the switch to propane? Exceptional availability and versatility. Our propane is delivered coast to coast in Canada. We serve every corner of the country, and propane can be used on your site for several applications, displacing other less friendly fuels. Economics and environmental performance makes it attractive to operators. The economics vary with each propane power application. However, the common theme is value. Today, Canada produces around 11 million cubic meters of propane per year, with approximately 50% being exported. Around 85% of Canada's supply is produced as a derivative of natural gas extraction. The remaining 15% comes from oil refining. The Canadian Propane Association reports domestic retail propane demands amounts to only 1/3 of the total annual production in Canada. So an abundance, coupled with our national delivery infrastructure, assures operators their energy demands will be met anywhere in Canada. In other words, propane is a reliable fuel source. Propane is recognized as one of the most versatile fuels and can power many operations based on the needs required. There are several different types of power needs where propane is the preferred choice. We'll go over those now. The first is prime power. Customers often choose to generate their own power supply when the available utility service is expensive, unreliable, or predominantly when it is non-existent. Propane generators deliver continuous power without the high cost of fuel and maintenance that comes with diesel generators. Next is combined heat and power, also known as CHP or cogeneration. Typically, about 2/3 of energy used to generate electricity is wasted in the form of heat discharged to the atmosphere from the power generator. CHP is generation of on-site electricity that also captures the heat from the generator that would otherwise be wasted to provide useful thermal energy, such as steam, hot water, or heated air that can be used for many applications in space heating, hot water in commercial or industrial applications, in motels, institutional buildings, mills and all industries, vehicle and equipment garages, or for use in commercial buildings and varied industrial processes, again, in many industries. The potential for CHP really is unlimited as to what you can use the reclaimed thermal energy for. This is how CHP basically works. The thermal energy is collected from the exhaust, the engine coolant, and even the engine oil through thermal heat exchangers. From there, the reclaimed energy is typically transferred to another heat exchanger in a medium of air or water for use in thermal applications on your site. So in essence, your CHP units works in conjunction with or displaces boilers, furnaces, and water heaters, their fuel sources, the emissions of those primary fuels, and the related cost of the fuel and taxes on those fuels. I can't say enough about CHP for prime applications. This is a great process that raises the overall efficiency of the generator while reducing costs and environmental impacts for your business. Then there's peaking power. So this is generating your own power during peak times as set by your local utility. Traditional utility prices involve a set rate per kilowatt hour. As most of us are aware, in recent years, electricity rate structures have been altered by many utilities across Canada. The rates can now fluctuate on a sliding scale according to peak and off-peak times, again, as set by your utility. Many companies who consume continuous power during peak hours can opt to generate their own power in a more cost-effective manner with an on-site propane power generator. And finally, there's backup power. Backup power is the ugly duckling of power generation and is often overlooked. Upon failure of the electric utility grid due to events such as ice storms in Ontario and Quebec, forest fires in BC and Alberta, or floods in other parts of the country, as well as other catastrophic events, and even automobile incidents knocking out a power pole, a propane power generator will automatically switch on and provide power to your operations until primary utility power is restored. Unfortunately, we've seen these events occur all too often in the recent past. We should consider how these types of events have affected our businesses. Superior Propane installs a power generator at all of our plants in weak electric grid areas. This way we can supply propane to your businesses when the electric grids we rely on fail. So we've discussed 4 types of power generation systems. Now I want to share with you the different types of generators and kilowatt outputs available in each category. There are 2 distinct types of propane power generators, those with a piston type or reciprocating engines and turbines. So propane generators with reciprocating engines are available from about 10 kilowatts to multiple megawatts individually. Propane turbine power generators similarly are available from 30 kilowatts to multiple megawatts, also individually. Both systems can be modular, so there are no need for a large powerhouse on site. They can be plug and play, meaning units can be added or removed easily as load demands. They can be synchronized with many units interconnected. Several small units are more reliable and more fuel efficient than one single large unit. Both systems are available in combined heat and power, and both can be utilized in conjunction with wind, solar, run-of-river, and biomass power systems to create a robust hybrid power system. Ultimately, with the right propane-powered unit, you can meet all of your business's power and heating needs. Now let's focus on the economics of propane power generation. Historically, propane has been significantly less expensive than diesel fuel, and prices have been remarkably stable. Depending on the market, per liter, propane costs up to 40% less than diesel. The graph you are seeing now on the screen is based on 1 million BTU or 1 gigajoule of energy for both diesel and propane. So the energy content here is equal. As you see on the graph, propane had a spike in January of 2014. The U.S. Energy Information Association reported that misinterpretation of information that year by geologists completely missed the looming polar vortexes. The warm winter that was predicted ended up with 2 polar vortexes occurring. Hence, the predicted oversupply of propane was sold to the export markets and caused a short-term rise in price, along with some anxiety for the crop dryers and other industries who weren't expecting the wet fall and twin polar vortex storms. You'll notice on the same graph, we see propane then fell below recent lows. This is what we call elasticity in markets. Typically, when a market overshoots, it can often respond with the exact opposite trend which it did before it rebalanced and resumed its former trend. So Superior Propane offers a wide range of fixed price solutions that take out the variability in your long-term propane supply. What we mean by this is that when we offer you fixed pricing opportunities for your product, it makes propane a reliable fuel for budget planners to better predict fuel spending estimates. When planning large-scale projects, predictable fuel pricing means less variances that push your budgets higher. Fuel cost is not the only savings, though. In fact, you may be surprised to learn of the true life cycle costs of propane prime power generators. Their true advantage stems not only from their lower fuel costs, but also from an overall decrease in operating costs. Propane burns significantly cleaner than diesel and with less particulate matter. Hence, with less particulate matter entering the crankcase of the reciprocating unit, there's less wear and tear on the internal engine components. The propane engines require less maintenance and without the added cost of additional fluids and filters, thus decreasing overall maintenance costs. Diesel engines require up to 4 times more oil changes than a propane engine. Propane-powered turbine generators also share a common theme with reciprocating units. The turbines also require less servicing and less downtime than diesels. Hence, the cost of downtime for service interruptions on a propane unit are far less than those of a diesel. Fewer service breaks means greater productivity, less disruption, and more uptime. And what about compressed natural gas or liquefied natural gas? Well, cost is initially low for the fuel. However, the savings from CNG or LNG are often negated by the high cost of transportation and for storage infrastructure for both fuels today. CNG is needed to be compressed to 3,600 psi, and LNG is similarly compressed, however also cooled to a temperature of approximately minus 160 centigrade. Alternatively, depending on the scale of the project, CNG and or LNG storage plants are at least 5 times more costly than propane storage plants. I'll share with you why that is. Substantial infrastructure is required to compress and or cool these fuels. So without the additional cost of on-site cryogenics, LNG storage plants will vent a percentage of their fuel to the atmosphere daily. Natural gas in its raw state is a greenhouse gas. So the choice is pay the additional capital and operating costs to refrigerate continuously, implement the vapor recovery system, or vent natural gas to the atmosphere. Propane storage plants do not require cryogenics or compression. Propane is not a greenhouse gas in its natural state, nor do we need to vent gas to the atmosphere that you've paid for. Now, if we compare propane and compressed natural gas in their vapor states for use at site, you'll see that propane holds 2.4 times more energy than compressed natural gas per cubic foot. This means fewer propane deliveries, resulting in less wear and tear and maintenance on lease roads, forest service roads, mine accesses, and private roads. So there's tremendous savings there. Finally, let's consider the current state of the market for propane versus CNG and or LNG. Propane has a mature supply chain network in Canada where most refiners produce propane. The transportation industry supporting propane has been in place for more than 6 decades, and propane storage tanks and vaporization equipment are readily available today. On the contrary, CNG and LNG supply chains are junior to those of the propane industry, not as robust, and at timelines for the equipment are 2 times longer from manufacture, and as mentioned earlier, significantly more expensive. So a current example today is LNG being transported to the Yukon from a refiner in the lower mainland of BC. That's due to the fact that not all refiners in Canada are CNG or LNG capable. That hasn't occurred yet. Again, I speak to the availability of propane across all geographies in Canada. We have a mature and robust supply chain network coast to coast to coast. So we know propane is less expensive than diesel and has a much lower infrastructure cost than CNG and LNG. Now let's talk about the environmental and safety advantages. In today's climate, businesses have become more sensitive to the environmental impact of their fuel choices. Propane has long been considered a clean fossil fuel, which is especially important to northern industries like mining, which operate near indigenous lands, and ocean-based industries such as aquaculture. Propane is much cleaner than diesel and poses almost no risk to the environment. I'll explain that to you here. Propane, when released to the air, has no negative effect on the environment. In its natural state, it is not a greenhouse gas. It's also a very stable fuel without the risk of contamination in long-term storage, resulting in an extended shelf life. Unlike diesel, propane never requires polishing. We actually have propane tanks in the Northwest Territories that are at a decommissioned mine that have been there for over 2 decades, and that propane is still 100% usable today. Propane has a low flammable range, a higher ignition temperature in air, and is odorized for easy leak detection, making propane safe for work in all of your work environments. Propane is non-toxic, lead-free, and is harmless if released in the air, water, or ground. Someone mentioned to me lately, Sean, we cook with propane, but we don't cook with diesel. That puts a little bit of a different perspective on the fuel. In fact, propane is recognized for its low environmental impact by Canada's Alternative Fuels Act. Propane's greenhouse gas and particulate emissions are significantly lower than most other carbon-based fuels, such as gasoline, diesel, and heating oil, as you see on the screen now. Propane also produces up to 15% less greenhouse gas emissions and 98% less particulate matter than diesel. It also contains virtually no sulfur, which, as we know, is a contributor to acid rain. This, to me, is a really troubling note. The World Health Organization has classified diesel engine exhaust in their Group 1 category, which is defined as high-emission substances carcinogenic to humans. Propane, in this instance alone, proves itself as a far superior fuel. As you've probably heard, there are several recent legislative regulations affecting commercial engine output. Tier 4 regulations first came into force in 2012, leading to further reductions in emissions from off-road diesels. The Tier 4 emission standards and the testing procedures are aligned with those of the United States Environmental Protection Agency. These standards essentially require manufacturers to reduce the levels of particulate matter and oxides of nitrogen at a level that is 50 to 96% less than the existing output of those pollutants from current diesel engines. Today, Tier 4 standards currently apply only to certain categories of engines, but by December 31, 2018, all engines will be required to meet the new Tier 4 standards. Just as a side note, the numbers are not yet available from the diesel manufacturers regarding additional costs for Tier 4 compliance. Industry is expecting an increase in capital costs for the diesels, a decrease in their efficiency, and an increase in operational costs. This will be similar to what the transport truck industry experienced as emission standards for them changed starting in 2008. In December 2015, at the UN Paris Climate Conference, Canada pledged to reduce greenhouse gas emissions to 30% below the 2005 levels by 2030. To support this effort, the federal government has mandated all provinces by December 2018 to create a program to regulate carbon emissions, or the federal government will step in with its own rules. Provinces can either institute a cap and trade program, as they did in Ontario, or levy a carbon tax like in Alberta. So carbon output is dependent on several factors, including the age and design of the genset, fuel type, run times, and load factors. So carbon penalties will vary from install to install. Either way, this new federal carbon tax mandate has heightened the importance of weighing environmental impact when choosing a fuel. A worthy note to recall for those operators that choose a combined heat and power solution, as we discussed earlier, a second fuel source and the related tax can be eliminated by the utilization of the thermal energy from the CHP unit. Remember that thermal energy was typically wasted to the atmosphere on basic generators. So CHP operators can realize a significant fuel cost and tax savings and emissions reductions simultaneously due to the single source fuel and the equipment from multiple outputs. These type of cost savings opportunities for business are pretty difficult to find today. We spoke earlier about the versatility of propane power applications. I'd like to expand on that by talking about the different propane solutions available and where they're best leveraged. In a prime power situation where 100% of your power needs to be generated, propane engines are best suited for new projects requiring power generation on site like a mine, remote tourism resort, camp, or construction project. Similarly, in situations where existing prime diesel generators are at or near their end of life or require repowering or rebuilding. And finally, those instances where additional power is required in an existing prime diesel powered application. In all three applications, propane power provides cleaner, more cost-effective energy. We'll talk about biofuel now. A biofuel-based engine is based on a traditional diesel engine with additional propane biofuel hardware. The system operates by blending both diesel fuel and propane in the combustion chamber. So propane biofuel allows you to displace up to 40% diesel fuel with cleaner burning propane, enabling the maximum fuel cost savings without compromising engine performance. Propane biofuel is best suited in applications where capital restrictions don't allow for a replacement of your existing diesel generators, where diesel generators were recently capitalized, where your environmental permits do not allow for additional diesel storage on site, and where you want to reduce your diesel storage or you have a need to increase your runtime with existing diesel storage. And finally, propane biofuel can be used for other stationary diesel engines, such as for dewatering, air compression, irrigation, and even ski lifts. As mentioned earlier, propane combined heat and power systems produce both heat and electricity at peak efficiency, and recovered waste heat is used to meet a facility's space heating, water heating, or cooling needs. These systems are most effective in off-grid buildings with significant and or steady thermal loads, which could include heavy domestic hot water needs like hotels, hospitals, or space heating through a hydronic system like in a greenhouse, in mills, tailings ponds, and varied industrial processes. As well as in a prime power application, combined heat and power systems can be ideal for retrofit situations where existing water heating equipment such as boilers or steam generators and equipment needs to be replaced. Operators looking to replace another fuel source or who are concerned about oil or diesel spills would be also well served by a propane CHP solution. CHP is the most efficient propane power application and provides the best ROI for a reasonable capital investment. So you may be thinking, this all sounds great, but I have limited capital budgets for new generators. That's okay. Many of today's power generator manufacturers, packagers, the installation partners, and their financial partners have financing options through various programs aimed at meeting your budgetary needs. Some of your options include, for instance, a standard lease or rent-to-own agreement financing the generator. This option allows you to finance your capital costs over a given time period. Another option we call integrated turnkey solution, or you may have heard of it as ITK. With an integrated turnkey solution, the partner will build the entire power generation system and financing will be done through a separate financial partner. So we're bringing two partners together to build the solution. And finally, there's what we call the boom option. This is where our solutions partners provide under a boom model and within the framework of a power purchase agreement, the system. So the boom stands for build, own, operate, and maintain. In this instance, the partner will actually build, own, operate, and maintain the power generation system. Under the boom option with a power purchase agreement, you keep the entire assets off your balance sheet, and you pay for power only as an operating expense. Depending on the size of the project, there are always several financing options available. For more information on the manufacturers and partners who have specific programs, please just reach out to me after the webinar. My contact information will be available there at the end of the webinar. We'll share the information with you then. So let's take a look at an existing off-grid Superior Propane customer. Agri-Marine Technologies is a Canadian-based aquaculture company specializing in fish farming and in developing sustainable technologies for commercial aquaculture applications. They were leveraging boilers to generate and regulate water for their fish tanks on propane, but were using diesel to power their farm. So environmental awareness in the fish farming industry is strong, as we're all aware. So Agri-Marine was eager to lower their emissions and eliminate the risk of potential diesel spill. They wanted a solution that complemented their in-house sustainable technology systems. So after looking at the potential cost savings and the environmental benefits, in October 2016, Agri-Marine opted to purchase a 700 kilowatt propane prime power generator. Superior Propane supplied the 30,000 gallon propane tank and the infrastructure behind it to supply the propane for the unit. The propane fuel is not only trucked, but it's also barged to this site. So we want to take a closer look at the business case that helped them decide on propane power. So Agri-Marine's daily power needs are on average 525 kilowatts per hour, 24 hours a day in a prime situation. That's about 4.6 million kilowatt hours per year. So for this business case, we determined that the baseload power was required for 4 years only, and we used a discount rate of 10%. The comparison you're seeing on the screen is for new propane powered generator against the new tier certified diesel generator in 2016. The propane solution provides an annual operating cost savings of approximately $328,000 related to both fuel and maintenance. Assuming the spread between the fuels stays the same, in 2.2 years, the savings covers the difference in cost of the propane power generator, and in the next approximate 2.2 years, the generator pays for itself entirely with the savings. So in the meantime, the diesel generator continues to have an operating cost of $328,000 higher than the propane unit. The marginal cost of electricity is 7.1 cents less per kilowatt hour for the propane unit. And as you can see, the internal rate of return on this is 29%, and the NPV is 314,000 based on 4 years. Some pretty strong numbers there. The results for Agri-Marine were immediate. They had clean, reliable power that was more affordable. They eliminated the risk of diesel spill that could affect their surrounding environment and fish inventories. And for Agri-Marine, it really aligned their farming process with their company philosophy of participating and promoting greener initiatives. So to summarize, we spoke about the history of propane-powered solutions in industry and how today's operators have more energy choices. We talked about the business value of propane power generation and its availability and versatility, the favorable economics and the positive environmental performance. We reviewed the environmental legislation affecting commercial engines and emissions, outputs, and how it has heightened the impact of commercial fuel choice. We looked at the different propane power solutions available and when and where they're best leveraged. We reviewed the options available to finance your power project. Finally, we took a closer look at the business case for a current propane-powered operation, Agri-Marine, and how they benefited from their move to propane power. I'd like to say thank you for your time today. I hope I gave you enough information for you to consider how propane power generation can improve your operations. Regardless of the system you choose, propane is dependable, clean, and cost-effective as a power choice. On the screen is my contact information along with our website URL for more information. Please don't hesitate to reach out to us here at Superior Propane regarding your propane power generation needs. We believe propane is the bridge fuel to the future. I'd like to now ask Tracy to open up the floor for questions.
Thank you. Thank you, Sean. We're now going to begin answering questions that were submitted during today's presentation. As a reminder, you still have time to submit questions to the questions pane in your attendee control panel. Sean, our first question is from Larry. Larry asks, is the diesel fuel cost used in the comparison on-road pricing? That is, at the pump diesel or diesel that is used for power generation?
In that particular instance, we used diesel that was priced for power generation, not on-road pricing.
Thank you, Sean. Our next question comes from Lake. What type of heat recovery system would be implemented to capture the excess heat from the generator? And also, is there a heat curve with generator types and sizes?
Yes, so what I'll do with that is I'll answer that a little bit, and then I'll ask Patrick to maybe weigh in a little bit more, Patrick from Total Power. So, Lake, the power generation system in that application would be a combined heat and power. So depending on the size of the genset and the load required on the genset, the CHP could take in either heat from the exhaust through a thermal heat exchanger. It could take the free energy from the coolant on the engine. And on a very large unit, you could even use the extracted heat from the engine oil. Maybe Patrick might have something a little bit more to say on that.
Yeah, typically on the cogen systems, you'll see pretty much all applications will do full heat recovery on the exhaust and main cooling systems, which do also include the oil. They'll range in size from anywhere as low as 15 kilowatts all the way to multi-megawatt units. The cogeneration units on the generator side, typically from an electrical perspective, will have efficiencies up to 40%, but then combined with the potential heat recovery, you can get total efficiencies of the complete system nearing 90%. So as a general rule, you can say that you will get a little bit more heat out of a unit than you will get power. So if you have a 1 megawatt unit, you'll probably get just a little over 1 megawatt of available heat out of that same unit.
Great, thank you, Sean, and thank you, Patrick. Our next question, are there good propane options for temporary installations like construction sites?
Yes, absolutely. They're a great option. So we do this a lot across Canada already. So small generators typically used in construction range from as small as, say, 20 kilowatts, and they go all the way up to, 70 kilowatts is pretty common, and then 150 kilowatts is a little less common. They come in varying control sequences where we can power multiple devices at the same time, multiple propane-powered construction heaters, fans, etc., lighting systems and tools. So it is common. It is regularly used today, and we supply those with propane tanks, typically depending on the size of the unit and its consumption rates, and the British thermal units required. Hourly, we size the tanks. We start down at the 500-gallon tanks all the way up to 2,000-gallon tanks and larger. Some sites we use mobile trailers, such as an 18,000-gallon mobile propane trailer, where we'd have a far greater capacity of storage. So we do use them currently, and we do have great options for you. If you reach out to us after the webinar, we'd be glad to share some presentations with you about power generation for construction. Thank you.
Thanks, Sean. Our next question. Are there any concerns associated with cold weather environments? Is a propane generator as a main power source for the off-grid community in a northern environment feasible?
Great question. Thank you for that. And yes, absolutely, they're feasible. So to answer your questions about the cold weather concerns, so there's two ways that we actually supply propane to a power generator. One is we can actually pump the propane over to vaporizers that are mounted on the engine. And what that does is uses the hot water coolant to actually vaporize the propane as it arrives at the generator in its liquid state. Otherwise, what we can do, smaller generators, typically we may actually vaporize the propane at the site in a northern climate with what's called a propane vaporizer. So that's something that actually creates heat and turns the propane from its liquid state to its vapor state to feed the generator. Predominantly though, on the large generators, we're actually pumping it over in its liquid state. Patrick may have something interesting to say about that as well. Patrick?
Yeah, typically the propane generators, as long as we are supplying them with liquid propane and convert to vapor at the genset, there isn't much of a cold weather issue. You know, and the other thing to keep in mind is similar issues exist on the diesel side of things, especially on the standby market where you see a lot of units getting filled in the summertime with summer diesel fuel, and then they become inoperable in the winter when they're actually required, or, you know, just even on prime units with the fuel gelling in the wintertime.
Thanks, Sean, and thanks, Patrick. I just want to take a quick moment to remind everyone, if you do have any questions, please just type them into the question and answer box, and I'll pose them to Sean or Patrick on your behalf. Sean, our next question is from Bruce. What is the largest generator you make?
So we don't actually make the generators. We actually supply the fuel and the fuel delivery and supply infrastructure behind it. But I'll share what I do know, and that is that generators can come in, typically we see them out there, there are often 1 megawatt generators, and there are other brands that come in much larger than 1 megawatt in reciprocating. And the turbines come in as small as 30 kilowatt, and they go up to some of the ones you can see, the very, very large ones are 40 megawatts. What I'll do is maybe ask Patrick to weigh in on that as well and share some of his insights on the size of the generators.
Yeah, the size of the generators are very, you know, quite varied, all the way from, like Sean said, from as small as 8 kilowatts all the way to multi-megawatt. Typically what you'll see in larger applications is that you start paralleling multiple generators together, especially if you're in a remote situation where your power needs vary. Then you're best served by having multiple generators that can come on and offline to handle a variable load. So, you know, you don't want any generator, regardless of the fuel type, to be too underloaded, and by having multiple generators you can handle the different load variances at different times of the year or even different times of the day.
Thanks, Patrick and Sean. Our next question, Tyrion asked, in terms of the footprint of a typical propane generator, how does this compare to a diesel or LNG generator?
So I'll give a basic answer on that, and I'll ask Patrick to weigh in as well. So typically, because propane has a lower calorific value than diesel, the engine for the same output in the larger categories or the larger kilowatt nodes typically needs to be a little bit larger. So our footprint might grow by 30 to 40% on the very large generators. On the very small generators, it's very similar in footprint. So under 200 kilowatts, the footprint's very similar. In regards to an LNG or a natural gas generator, they're the same unit. As a matter of fact, most propane generators and natural gas generators are very similar in design. The compression rates are different and some other technical data is different. However, they're roughly the same size. So maybe I'll ask Patrick also to weigh in on that.
Yeah, no, I think you've hit the mark. You know, the propane generators are spark ignited engines, which have less output for the same size compared to a diesel. But keeping in mind, the engine's only one small part of the complete package, and so it only increases the size of the package marginally compared to, you know, your traditional diesel gensets.
Thank you. Our next question comes from Bruce. How is the propane generator affected by cap and trade programs?
Okay, so that's a really great question again, Bruce. So the way that we've talked about it in the webinar stands to be true. Each individual generator, depending on the design and manufacture, the fuel quality that you're using, the type of fuel you're using, the load characteristics, all of those are going to affect your output for your cap and trade situation. So when we go head to head against different types of equipment, each each unit is going to produce different emissions in every application. So what we do is we take professionals like our partners and we actually have them do a analysis on the specific engine as it's designed to meet your application, so that we actually produce a document from them, from the manufacturer, that says what the exact outputs will be. So you can calculate that towards your permitting processes, or if you want to use that in your literature on your website, etc. We can share that data with you right from the manufacturers. Each one of them is going to be different though.
Thank you, Sean. Our next question comes from Mark. Mark asks, for greenhouse applications, I heard there is a way to use a CHP unit to fertilize the plants. Is this true? And if so, how does it work?
Yes, that is true. And Patrick will get you to maybe share something on that as well. So propane prime power generators produce very little emissions anyways. So off of the exhaust system, we can do a couple of things. One is you want to extract that thermal energy off the CHP unit and use that thermal energy to heat the greenhouse. Simultaneously, as that exhaust comes off the generator that has much less emissions than diesel, we lightly strip that exhaust and remove any partially harmful emissions. We put the CO2 into the greenhouse. This does two things. Not only does it fertilize the plants through what we call CO2 fertilization, but we also are now taking your genset down to a lower emissions situation because we're actually feeding that CO2 to the plants. So they do exist, they are out there, and they're very effective. Patrick, do you have anything to add to that?
Patrick, are you muted?
Oh, I'm sorry. Yes. No, Sean, I think you covered that quite well.
Thank you, Patrick. And just a reminder, if anyone does have any questions, just type them into the question toolbox, and I'll ask Sean or Patrick. Our next question comes from John. Can Superior Propane deliver to coastal islands?
Yes, so currently we have, in British Columbia alone, we have 3 partners that deliver propane on barges. And we can deliver to many applications on coastal locations in British Columbia. So it depends on what the client has at their site for us to actually dock a barge and to have propane come off of that barge onto your site. So if you have a specific site that doesn't have great access, just share with us, bring us an invite. We'd be glad to take a look at your site and see what we can do to help with our partners that are in that business to help make your site suitable to bring a barge in to deliver propane to your site. So the answer basically is yes, we can, and we do.
Excellent, and thank you, Sean. I'll just give everyone just one more moment. If you do have any questions, please just type them into the question toolbox. Also, you can just reach Sean at his email address above if you do have any more questions. Oh, and I think we're getting another one in. Just one moment. Chad asked Sean, can you comment on the difference in efficiencies between turbine-powered and reciprocating engine propane generators? And also, is there a power threshold where one becomes more efficient than the other?
I would designate that question over to Patrick. That one's a little more sophisticated on the efficiencies of the reciprocating versus the turbine. So Patrick, could you take that one?
Yeah, typically the reciprocating engines have a much higher efficiency than the turbines, and especially if you're in a variable load situation. Turbines require a lot of air always coming into the engine, which needs to be compressed. So if you're under light loads, turbines can typically become much less efficient than if they're fully loaded. You typically see on small applications all the way up into the smaller multi-megawatt systems, reciprocating engines are definitely the winners. Where you see turbines really coming into play is on a very large applications, 5 megawatts and above, where they have continuous use for that power, for example, tied into the grid, or having a plant that is using all of that power all of the time. So if you want efficiency out of a turbine, typically you need to have them fully loaded.
Great, thank you. Our next question comes from Tyrion. Taryn asked, I haven't heard too much from equipment providers carrying propane generators in their fleets, as it's typically either diesel or natural gas. What equipment providers are there in the Canadian market?
That's a great question. So some of the equipment generators out there currently, we deal with many. We are equipment agnostic at this point in time. So there are manufacturers such as, well, Total Power uses GE's equipment, Waukesha, there's Jan Bacher, there's Cummins, there's Finning Power, Cavalier Industries, there's Flex Turbine, there's Capstone Turbine. There's many applications out there that are available from many manufacturers. Maybe, Patrick, you could mention a few of the manufacturers that you guys also use.
Yeah, on the cogen side, Titum is a prime manufacturer that we use, and they have a number of sets for the cogen side capable of natural gas, on propane. Also, we try to look at using propane-powered engines that are more of an industrial breed versus an automotive breed engine, so that we can, ensure long life expectancy and make sure that you have the same type of reliability, if not improved reliability, over the diesel applications. In the standby market, Generac is a big player that we use. They're one of the leaders, especially in the smaller standbys, all the way from backing up residential applications all the way to larger applications. And they have a number of propane acceptable engines ready to go for those applications.
Thank you, Patrick and Sean. I think this is our last question. Just again, a reminder, if you have any questions, just type them into the question box. Sean Kingsley asks, what is the life expectancy of a propane generator versus diesel?
So I'm gonna give my answer on that, and I'll ask Patrick to weigh in as well. So depending on the grade of engine that is utilized, if we're using an industrial automotive engine, we can expect somewhere around 20,000 hours for the life of that unit. Where we use, like Patrick mentioned, an industrial grade, and it's a diesel style engine. So when you look at that engine, as you've seen some of them in the presentation, they look like a diesel. They basically are an exact model of a diesel block, and they're designed specifically to run on propane as a gaseous fuel. So that unit has a life expectancy almost exactly the same as a diesel. Some of them claim to have 40,000 hours on the bottom end, and some, the GE Waukesha, actually states in their brochures that they can get up to 80,000 hours on the bottom end. So we're looking at very similar on some styles, and we're looking at extended life on other styles. So again, it really varies based on the style of engine that's chosen, and that engine is chosen based on your application, whether it's prime or whether it's backup or whether it's peaking, etc. So maybe Patrick can share some information on that as well.
Yeah, one thing to keep in mind on the industrial style spark ignited engines, which we'd use for propane, they are off a diesel derivative. So the bottom ends and everything come from basically are very similar to the same sister diesel engine that it is derived from, but also having a lot less load going through that engine because the power density is smaller in that engine. So you're not working a lot of the components in that engine as hard as you're working on a diesel. Along with the cleaner fuel, allowing for cleaner oil and such, that's typically why we see longer life expectancy on propane-powered engines.
Thank you. And we also have a question from Steve. Do you have a comparison between propane and diesel fuel prices and delivered in diesel terms, i.e. money diesel liter equivalent?
So that's a challenging one because everywhere, Steve, across the country, propane and diesel are at different rates. So the refiners, every refiner across the country has a different rack price. Simultaneously, the location from refiner to distribution to client is different for every location. So it's hard to peg that down, but I'll tell you what, if you reach out to me after the call and give me a location, we'd be glad to give you some pricing information on both fuels, depending on where you are.
Excellent. Thanks, Sean. And Sean, we seem to be at the end of our questions. I would like to say thank you to everyone for joining us today. And thank you to Sean for presenting the webinar today. Just a reminder, you're also going to receive a follow-up email within a few days with a link to view a recording of today's webinar. And on behalf of Sean and Superior Propane, thank you for joining us today and have a great rest of your day.